Hello, today we're going to talk about applications of linear functions. Alright, basically this entire lesson is about making equations from tables and graphs. Alright, so the equation you want to make is this. This is called the slope-intercept form. This is the y-intercept, which is the place where your line crosses the y-axis, and this is your slope. Right? Your slope can be found with the formula that. Alright, so it's the change in y over the change in x. And this is what you're going to use. You'll be able to find the y-intercept and the slope, and I will show you how to do it. It's very easy when you have a graph and you have a table like they have in here. It makes it simple. Alright, our first example is this table. What we're going to do for all of our problems today is we're going to find the equation. It means finding the slope, the y-intercept, and writing it in this format. Alright? So the first thing I always like to do is find the slope. So, find slope. Or the other name for slope is rate of change. It has to be constant. So you see constant rate of change. So yeah, here you go. This is basically telling you, if it's asking you to find if it's a constant rate of change, you just do the slope for all of these and then figure out if they're all the same. If I find the slope here, here, and here, and they're all the same, it's constant and it's a linear function. Alright, so we're going to find the slope first. I'm going to take these 2 points and plug them in. Now I'm going to rewrite this for you because I don't like this way this is written. I like it written as points. So all I did was take this and make it into points. That's it. So still x, y, x, y. So I do this my own way. If you don't want to do it my way, you don't have to. So I label this as 1, and I label this as 2. I label my x and my y, my x and my y. So now that this is 1, I put a 1 there and a 1 there. Since this is 2, I put a 2 there and a 2 there. That way I know where to put them in my slope formula. So my slope equals, I'm looking for my y2, 282, what's my y1? 232, over, what's my x2 is 1, my x1 is 0. So when I solve this, I get 50 over 1, so 50. So of all the pieces I'm trying to find here, I'm trying to find my m, and I'm trying to find my b. Nothing else really matters. So my m is 50. So let's write this in pink over here. So y equals blank x. So now I can fill in, my slope is 50. Now the only thing I'm missing is my y-intercept. But how can I find my y-intercept? Alright, there's a couple ways to do it. But I'm not going to show you all of them right now because it doesn't need to. They give you an out on all of these. So your y-intercept is where your line crosses the y-axis. So if it's crossing the y-axis, your special line here, if it's crossing right there, where's it at on the x-axis? It's always at 0. So whenever you have your y-intercept, it's always 0 and some number. Alright? So when you're looking at a graph, you look at where the x is 0 to find your y-intercept. When you're looking at a table, if you have a 0, that means that is your y-intercept. And there's your equation from it. Alright, for our second example, we're going to do another table. But this time we give it fancy names instead of x and y. Say year and rainfall. The top is always your x or your domain or your input. The bottom is always your y or your output or your range, whatever you want to call it. It doesn't really matter. So the first thing we'll want to do, because now we're going to find the equation with this. So let's find the slope first. As I told you before, I don't like doing it out of the table, so I'm going to make these into points. But when I make this into points, I have to do this a special way. So I'm not, well, I'll use it like this, that'll be fine. So I'll make this, I'm going to write the whole thing now, because these are actually years. So 2004 and 75, and then 2005 and 74.3. I just wrote 04 and 05 because I didn't have enough distance on the board. So then I label it, call this 1, call this 2. It doesn't matter which one you call what. I can call this 1 and this 2. It doesn't matter. I'm going to put on my hat because my bald spot's pretty prevalent because I haven't cut my hair in a while. So that's my X, that's my Y, that's my X, that's my Y. So that's 1 and 1. Those are my 2's because I labeled that 2. I can label it the other way, it doesn't matter. The slope will always come out the same. So I'm looking for my Y2 first, which is 74.3. Looking for my Y1 now, minus 75. Uh-oh, that's going to be negative. It doesn't matter. And 2005 minus my 2004. So that gives me negative 0.7 over 1, which equals negative 0.7. Ooh, a negative and a decimal. The world's going to end. No, it really doesn't matter. At all. So now, thankfully, they were nice enough to still give us our intercept. So what this is it doesn't say 0 there, does it? But if this were a word problem, I would say, so starting in the 2004, they started taking the average rainfall of your backyard, all right? And this is what they got, all right? So starting at 04. So if they start at 04, that means that is the very beginning. If you're looking for the beginning, that means 75 is your y-intercept, because that's where it starts at. So that's your B, that's your y-intercept. All right, here's your example 4. So I was just gonna do X and Y, but I decided to do different stuff. So acres of trees, so for every acre of tree, how many ninjas do you have there? All right, because it really doesn't matter what your X and Y is, it doesn't matter really anything, because all you're doing is finding the equation. So I'm gonna find the slope. Again, I'm gonna take this out. So I'm gonna say 0, 86, and 194. So that's 1, and that's 2. Actually, let's get crazy with it. Let's say this is 2 and that's 1 this time. Oh no, what are we gonna do? Same thing we always do, Pinky. All right, let's call that 1 and 1. Let's call that 2 and 2. Now we have to put it in the slope formula. So 86 minus 94. Oh no, it's gonna be negative. Our world's gonna end. Oh wait, no it's not. Because they're both negative. So if you have negative top and negative on the bottom, it simplifies to just 8. Because anything, a negative divided by negative gives you a positive. So you have a calculator, use negative 8 divided by negative 1, and you get 8. So there you go, there's your slope. So y equals 8x. Now we have to find what our y-intercept is. This time we actually have a 0, so plus 86. Now we're going to use that equation to find the answers for, if I have 3 acres of tree, how many ninjas do I have? If I have 4 acres, how many do I have? So anytime you're around 0 trees whatsoever, know there's always 86 ninjas around you planning to attack you. Just letting you know. All right, so let's figure this out. So we need to figure out when there's 3 acres. So I used my formula, y equals ax plus 86, not my formula, my equation. and I plug in 3 for the x, because that's what this is. This is the x. We're looking for the y. So we plug it in. So we say 8 times 3 plus 86. So that's 24 plus 86, which gives us 110. Now, I'm not even, well, I'll do the other one too, because I know there will be people that ask questions. So what if I have 4 acres? Man, imagine how many Winnie the Pooh has. He lives in a 100-acre woods. He has a lot of ninjas. Bet Christopher Robin's one. So 32 plus 86, 118. I wonder if they're all ninjas then in Winnie the Pooh. If they live in a 100-acre forest, there's a lot there. I wonder if Winnie the Pooh is actually just a training ground for ninjas this whole time. We didn't know. Tigger is pretty jumpy. Rabbit always hides in the hole. You have the owl, the wise one. You have the grumpy one in Eeyore. It makes sense now. So, the 100-acre forest, there's the 1,000-acre, 100, whatever acre forest it is. It's actually Naruto. You're welcome. All right. So this actually makes sense also if you don't do the math. So 86 and 94. How many did it take to get there? 8. 8. So then if I add 8 to 102, I get 110. If I add that to it, I get 118. So there you go. And that is how you find the missing one. That is how you find it algebraically, and that's how you find it just using the table. That's how you find the equation. We're going to do one more, and it's going to be from a graph. All right, here's our last one. I know it's been a long video, but we'll get through it together. All right, this is from a graph, and thankfully they gave us 0 here, so that's going to make things a lot easier. So we're going to find our slope like always. It doesn't matter which points you take. It doesn't whatsoever. I can take this, just make sure they're right by each other. It makes things a lot easier. So I can take these two, these two, these two, these two, or these two. I always take the one with the 0. So I'm gonna take 0, 300,000. I like zeros, they make things a lot easier. 2 and 2, 150,000. So I'm gonna find my slope. Let's go this 1, 2, x, y, 1, 1, 2, 2. I'm gonna go a little bit faster here, because you can pause it. Oof. 0 minus 1. 0 minus 2. There we go. That's what happens when you go fast. So 300,000, 0. Should be 300,000 minus 250,000, 0 minus 2. Yep, that's 1 point. That's the other point. So I get negative 50,000 over 2, which gives me negative 25,000. So that's my slope. Now I just have to find my y-intercept. What is it? It's right there. So for every, whatever amount of time this is, let's say hours. So for every 2 hours, you burn 25,000 of whatever. All right, this has been applications of linear functions. We discovered that Winnie the Pooh's group is a bunch of ninjas in the 100-acre woods based on a graph. That's cool.